Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X, the true cause behind coronal holes. Now, in observing the larger objects belonging to the Planet X system of stellar cores in the Sun's corona, which are dead or energy-depleted stars, I have noticed that these objects seem to come very close to the Sun's surface, and yet do not collide with the Sun. The smaller ones are often observed to be inside the Sun's inner corona, which goes out to a distance of half a solar radius from the Sun's surface. The larger ones are usually observed outside the Sun's inner corona, but inside the Sun's outer corona, which goes out to a distance of 12 solar radii. So here we see one of these objects. This is a dark stellar core. It is inside the Sun's inner corona, very close to the surface of the Sun. There's actually another one here. This one is covered in coronal plasma already. This one is drawing material from the Sun through this gravitational vortex that we see under the object. So these objects cause gravitational vortices on the Sun, and they look almost like a root-like connection, but these are vortices, and they're pulling material from deep within the Sun, most likely from the chromosphere. I've written about that. And of course, when they come close to the Earth, and they also come inside the Earth's atmosphere and do the same thing. And I've written several articles about that. Now, this is one of the larger stellar cores that have been observed close to the Sun. This is from a LASCO C2 image from July 23, 2017. And the object is seen here moving away from the Sun within CME material. And this is because the objects actually provoke the Sun into having CMEs. Now, size comparison with the Sun, and the size of the Sun is indicated by this white circle on the occulter, indicates that this object was about the same size as the Sun. But it is, in this image, well outside the Sun's inner corona, which will only go out to about, half a radius of the Sun, about there. So the object is outside, but the fact that it's moving away with CME material means that it may have come as close as inside the Sun's inner corona before it was ejected and started moving away. Now, this is another object. This is an extremely large object, and the image comes from a LASCO C2 image from 2014, as you can see, and it was sent to me by Owen Steiger. And here the Sun seems to have a strong reaction to the presence of this object, which you can see here. This object is huge. It's about 7 times the size of the Sun. The size of the Sun is indicated by the white circle. And as you can see, it has to be very close to the Sun, because you can actually see some of this plasma coming from the Sun in front of the object's edge. So the object has to be extremely, extremely close to the Sun. And when I draw the circle indicating the full outline of the object, you can see that the object came extremely close to the surface of the Sun. So this means that both small and large objects come very close to the Sun's surface. Now, the reason why the objects do not collide with the Sun is because once they make contact with the Sun's outer negative layers, there is an electrostatic repulsion between the object's positively charged core and the Sun's positively charged core. And you may look at Article 193 entitled Stellar Cores in the Sun's Corona, Why Do They Not Collide with the Sun, for more details on this. But this is illustrated here, how the objects, the stellar cores, which are mainly positively charged, they operate like positively charged ions, but super ions because they're very large. They're not atoms, but yet they operate like atoms that have lost electrons. They do not have an outer negative layer. They only have a neutral outer layer and a positive interior. But when they come close enough to the sun's outer layer goes out to envelop it. Well, at least that's what happens eventually. And at that time, the positive charge inside the core becomes detectable. And it has its effect on the object, and then there is electrostatic repulsion between the two, which here, as you can see, is illustrated by this orange arrow. And that electrostatic repulsion opposes the gravitational attraction that would tend to keep the object moving towards the center of the sun. So it means that they can hover very close to the surface of the sun when the two forces are in balance. However, as one of these stellar cores approach the sun, we can expect the sun's corona to first be repelled by the object because the gravitational interaction gives rise to a repelling force being exerted on the electrons, which make up this outer layer of the sun. So this is illustrated here. This causes a coronal hole to appear on the surface of the sun in the region facing the approaching stellar core. So as the stellar core approaches, this area on the sun that's facing the object develops low density. In other words, the electrons are forced away from that region. They may accumulate somewhere else. So the coronal hole will grow in size as the object approaches. So this is what we see here, the coronal hole growing in size. But as the distance between the two objects closes, eventually the two gravitational fields will connect so that the sun's outer layer corona envelops both objects. So this is what will occur eventually, and this is when the object will start drawing material, be close enough to form a gravitational vortex with the sun and draws material through that connection from the sun. And with that material, it draws energy because this material is much higher in gravitational energy than the particles that make up the object. So the object, once it gets as close as possible to the sun, will draw material from the sun. The absorption process will cause an increase in energy in the area, which will eventually lead to an explosive reaction which ejects the stellar core. The stellar core is thus ejected, but it leaves with some of the sun's coronal plasma and thus electrons. These electrons will most likely be absorbed into the core as the object is low in energy, so that it is not able to maintain a negative outer layer. The process is not instantaneous, though. It takes time. Once the energy and electrons are absorbed, the object will return to the sun, and the process repeats itself, with the object drawing some energy and electrons from the sun each time. Thus, over time, the sun's energy and outer electron layer becomes depleted until the sun starts to look darker than usual and its whole corona starts to look like one large coronal hole. So the object here is leaving, and the sun is left with less corona because the object took some of that corona away with it. It also took some of the chromosphere, so it's very likely that the sun's chromosphere has shrunk in size considerably too over the past few hundred years when these objects have been coming to the sun to draw energy from it. Now, here is an image from 2011 and another image from 2017. Both of these images are 3 years away from the last solar minimum, but you can see how much darker the sun was at the end of 2017. So this is from December 30th, 2017. You can see how many coronal holes there are. It's obvious. It seems like the whole face of the sun is opening up with coronal holes. So the most pronounced coronal holes are likely to indicate the presence of stellar cores some distance from the sun, which were making their presence felt on the sun's outer negative layer or corona. As I have indicated in recent articles, it is likely that the images shown above are much older than the timestamps would have us believe, and that the sun is now dark most of the time or has become permanently dark due to the draining effect the stellar cores have had on it for hundreds of years. And for more details on that, you may look at Article 291 entitled "The Sun Disappears, Day Turns into Night," Article 351, "The Sun is No Longer Shining," and Article 361 entitled "Planet X Producing Gravitational Vortices in the Earth's Atmosphere Since 1643." However, the images we have, even if they are older than they seem, still allow us to observe and learn about the interactions between these objects and the sun, and thus gain understanding on how the universe we live in functions. In conclusion, the appearance of coronal holes on the sun are an indication that stellar cores are approaching the sun, and the sun's corona decreasing size is an indication that a great many stellar cores are reaching the sun's corona and have drawn large amounts of coronal plasma and have thus caused the sun's supply of electrons to decrease. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.